Chapter 4 worksheet, question 16. We want to solve the logarithmic equation log base 2 of x plus log base 2 of x minus 1 equals 1. We'll start by writing our logarithms as a single logarithm. So addition with logarithms is changed to multiplication since logarithms are exponents. So we change this to a single logarithm log base 2 because our original logarithms are base 2. And then instead of adding, we are multiplying the arguments of the logarithms, x times x minus 1. Go ahead and distribute that out. So we have x squared minus x. So we multiply x times x and x times negative 1. Now we take our logarithm equation with one logarithm and we change that to exponential form. So to do that, we take the base of the logarithm, which is 2, and what the logarithm equals, which is our exponent, 2 to the first power. And that's just going to equal the argument of the logarithm, and now the logarithm is gone, and we have a lovely quadratic equation to solve. So 2 to the first power is 2. Subtract that over, we have this quadratic, we factor it. So x times x is x squared, negative 2 times positive 1 is negative 2, and negative 2x plus positive 1x is negative x in the middle. Using the zero product property, that gives us the answers x equals 2 and x equals negative 1. But wait a minute, we are not done yet. We have to check our answers. That's like super important step with logarithms. So when we check our answers, if we plug in at 2, log base 2 of 2 is fine, and then log base 2 of 2 minus 1 is fine too. You could even simplify that and see that it really does equal 1. But then if we try to plug in our negative 1, log base 2 of negative 1, or log base 2 of negative 1 minus 1, which is a negative 2, then we end up taking logarithms of negatives, and that is not possible. So a little delay in my writing there, so finally caught up to me. It looks a little weird, but anyway, that eliminates this answer, and so our final solution is simply x equals 2, because the other one's extraneous, it doesn't actually work.